Hello, here we are in section 3. Yesterday, last Friday, we covered quite a bit of the enemy controller in the navigation module. So under either enemy, you have the enemy controller, because that kind of like the big manager, it's keeping track of everything else. And somewhere in the hierarchy is the detection module. Now that the AI stuff starts here, trying to figure out if it can see an enemy of the enemy, which would be the player, and what to do about it. So that was the enemy controller script and the detection module script. And so the enemy controller script, it's keeping track of a bunch of renderable stuff, so it can change colors on the model when needed. It's got some high-level events for the enemy, and just registers a bunch of stuff on start and an update. It basically just sees if it gets calls the detection module, see if it can handle target detection, finds a player, and that's about it. If it should flash white if it was just hit recently, and if it's out at level bounds. There's a bunch of stuff down here. Some of the stuff I'm gonna have to get into today, but when it loses a target, undetected, orient towards, some pathing stuff, quite a bit of pathing stuff, damage and die, connecting to the health script, on drawing gizmos for debugging, orient the weapon, try to attack, try and drop an item, find initialized weapons, get current weapon. Okay. And detection module. So we went through maybe like half the enemy controller script. In the detection module, does it have any? Oh yeah, it does have some events up here. Registers itself, finds the actors manager, and handle target detection is the big one. Basically, it's looping through all the actors in the actors manager, and if the actor is not on your team, then we figure out what's my detection range, and we shoot a physics raycast from us to them, and that physics raycast is going to go through colliders on us. It's going to go through colliders on the environment. It's going to go through colliders of whatever we're aiming at, the opposite team actor. And then for each thing that we hit, we kind of sort through it. We filter out the self colliders, and if we have some valid hits, we store them. And if there was a valid hit, we see, was that the closest valid hit of this this array of raycast hits? Was the closest one the actual actor that we were seeking to hit? Meaning, was there no walls and floors or whatever in between us? And that means like I have a direct line of sight. This other actor who's on the other team is within my range, and there's nothing blocking my vision of them. So I should say, hey, I did find something. That's basically the main. And then is this did I just detect or did I just lose the target? Is the big AI for the enemies. And then there's some other event subscribers that get called that I'm going to be covering today. All right. So that was last week, and let me just. Oh right, Friday. That's why you said Tuesday, because there was no class Friday. Good call. So we have lecture today. We have lecture on the 5th. We have lecture on the 9th, and then we have quiz on the 12th. And there's quite a bit. I listed out kind of all the parts I still have yet to cover that are of some main significance in first-person shooter. And so I'll probably try and cover like this today. Let's see how we do. So as far as what we covered was really the communications between enemy controller and detection module, and then some parts of the detection module and enemy controller we have not yet covered. So let's move to another script now, because we kind of started our journey starting from enemy controller, and then we kind of saw how it was going back and forth with detection module in that update loop in the enemy controller script. But notice that the hoverbot has this enemy mobile, and the turret has enemy turret. And this is another big piece of the puzzle before we move into the weapons manager. So this allows me to see how this script is communicating with enemy controller and detection module and the weapons and with the animators. And this is going to be like another big puzzle piece for how the enemies are working. And I was just seeing if I should do turrets or mobile first. I was hoping that turret was a little bit easier to handle because he's not moving around, but his AI states are simpler. So let me start with this. So enemy turret script. We do require a component. We must have an enemy controller component on the same game object for this to function. And right off the bat, we have an enum that has been declared. So our AI state type, which is an enum, and there's only two states in the AI state. That's permissible, idle, or attack for the turret enemy. And they're going to have numbers associated with them because they're an enum. Now we have a bunch of properties that have been exposed in the inspector, and then some fields that are private that we can manipulate only on the object itself, and then some constants. Constant strings on damage is active. Sure. So this seems to be like animation settings. So we'll see how this connects with the animator. On start, go out, get the health component, get the enemy controller component, go subscribe these methods to these enemy controller events. So when we detected the target, we'll get this called, and when we lose the target, we'll get that called. Cool. Remember the rotation offset between the pivots forward and the weapons forward. Sure. So this thing must let's see what we got here. Oh wait, sorry, that's the hoverbot. So turret pivot is all the way down here. It's like the base joint that this thing moves on. Okay. And the weapon root is this thing here. All right, so it's not a model, it's just an empty transform where we can where the weapon will be aiming. So I guess the weapon's allowed to move different than the turret rotation, and there's going to be some offset that we're just need to be aware of. Sure, but we're going to start at in idle state. And time started since detection negative infinite. Remember I was saying when we're looking for highest or lowest situations, we might set to positive, negative infinity, or maybe 0, depending on what we're trying to move towards. So it looks like on update, we're going to call this update current AI, and on late update. So late update means wait for everything, every game object, every component to run its update methods. And then anyone that wants to run anything in late update right after that is allowed to do so on that current frame. So there must be some reason. I make sure everything else is done for that update, and then we can run this turret aiming method. And if I move down, looks like we just have update current AI and update turret aiming. And we have on damage and on detected and on lost. So I'll cover those later on. Damage is coming from the health script. So switch. So switch and if else are the two branching operations we got. And switch is really useful for enumerations, or when it's not just like a simple like if or an else, where it's just like you're checking for more than two conditions. But here it's just attack. Actually, there's just one. But usually with enums, it's preferable to use a switch. It's easier to read. So we're switching on whatever our state is, and if it's attack, if the case is attack, we're going to do all this, and that's it. We don't even have anything for idle. It just sits there idle. So somehow we get moved into attack, and if we're in attack, we can do this. So I'm guessing we get moved into attack when... So we here on detected target. So who do we subscribe to? Oh, the enemy controller. So if you remember, enemy controller has a bunch of methods, events, attack, detected, loss, damage. And usually what happens is somebody is setting this, and then the enemy controller is like, okay, I'm aware that like this AI state just changed. I'm going to go tell anyone else who's interested. So on detected target, that's coming, remember, detection module is figuring out when this should happen. An enemy controller is listening to it. And then it just broadcasts its own event. And so it looks like that's getting trickled down into enemy turret. So these are called after detection module figures out whenever these need to call, and gets funneled through the enemy controller. And so basically on detected target, if we're in an idle state, we're going to go to attack. And for all of our on-detect VFXs we have in an array, we're going to play them. So let me shrink this all up. So we must have some type of VFX array. Looks like just the death ones are being shown publicly. So let's go take a look at this on detect VFX. Oh no, it's a public particle system array on detect. Oh, so it's the random. Look at this tooltip here. Oh, enemy turret. Sorry, I was looking at enemy controller. So enemy turret. Sorry about that. On detect VFX. All right. Looks like we got two things here. We got an alert VFX and we got an angry stream. So it looks like all these things get played at the same time. So I'm not really going to cover a lot about the VFX because I spent that one class on it. But you see it just raises this exclamation point. You can always look in the VFX system on how they do it. But it looks like it's just like one particle like comes up. It's like a billboard. And it looks like it's just showing this graphic and it does that fun dance and then it goes away. Now also this angry stream. I'm compiling a shader. 1 second. Okay. Okay, so it looks like this dust cloud. Oh, angry steam. Okay, I get it. So he must play an animation too, where he like jumps up, where he must raise up really quickly, and this like steam is coming out from him. So let's just play real quick and see him in action, so you can see all this stuff together. You can see the animations are playing as well before we pick it apart more. Okay, there's the steam. Okay, it's synced up where he actually stands up, and then right before he starts shooting, the steam comes up. Cool, they timed it up well. All right, so that's the steam. So undetected. So we play all of them, which there was 2. And looks like we create a sound effect. Sure, it must play some type of sound effect. But since I can't play the audio to you, it doesn't matter. But if you wanted to piece that together, it is right here, turret alert. this sound file right here. Okay, cool sound. You can try it out. So animator set bool. All right, so now we're being introduced. We haven't actually. Yeah, I was showing you quite a bit of the animators, I think, in the 2D platform, but not so much here. So now we're kind of opening up, or maybe we were looking at the animator on the weapons in first-person shooter, but this is going to be definitely. These enemies seem very complicated, so this will be like a next level. But somehow we're going to set some bool on the animator, and then we're going to say time started. That we're going to record when we start detecting. All right. So let's see who the animator is. If it's a script sitting on here, or it's actually, oh, there it is, turn robot. So here's the animator. I'll open that in a second. What are we doing? We're passing a bool, setting a bool on the animator. And it's this constant, see if I hover, it's a constant string called is active, and we're setting it to true. All right, that was the two strings up here. All right, so it is active. So let's see what we got here. Let's go open up Animator. And let's zoom over to the turret. And let me see if I could trick it. Let me see if I can trigger these different states here. So it looks like we have idle, attack. Oh, I didn't want a good look. I'm going to go into scene view. Okay. So this is idle. So it looks like he's looking around. Let me turn off the gizmos. See a little better. No, you want to click on the floor. Okay. So here we are. Default state is idle or loopable animation. He's just looking around, all his body parts a little jiggly. And let's say is active. Let's see if I can jump him. Yep. Cool. I got him into, there's this a transition. It's like this animation just plays once. So we transition into this animation, play it once, move right into this animation, loop on it. It's just like really aggressively stuttering, looks like. And if I turn this off, yeah, he goes to attack out and back to idle. So this bool is really jumping us from that attack loop back to the idle loop. And let's see what happens on damage if I hit this. Let me see, does it have to be? Oh, it just happens so fast. Okay. So if you notice his head like jostles to the side a little bit, I'm clicking, and his head is kind of jostling to the side. And if he's down in idle, his head just gets jostled. Now notice there's nothing in these 4 states that are showing this damage, and so this must be on another layer. Looks like we have a damaged layer. So here we're on a different layer, and I'll get into layers are either additive or override. But here we're just sitting there, we're just looking around. Null, no damage. And if I go back to parameters, I click it, look, passive hurt and exit. And somehow there must be this, I don't know what this active hurt is. But when we exit this. This is like really pointing back to null. It's just saying when we exit, we're going to enter back again. So it's like we jump to here, and then we jump over to here and come back to here. And so now we have 2 layers, and the base layer, notice it's like our first layer of animation. Its blending is override, and notice damaged is additive, and we have some type of mask weight. I don't know what this MA means, but what's important is usually have a base layer. It's called override, and that means if there is anything existing, anything else playing on this thing, even if it's some weird connected way, don't worry about it. Just overwrite. This is my main base layer. And then you might have other layers that have additive effects add on top of the previous layer. So whatever the base layer is doing, whether it's an idle or attacking, it doesn't matter. We're going to add this damaged little animation on top of it. So no matter which angle he's at, and if he's passive or active, he'll still get this little damage. Oh, I see. Active hurt. So means he's active, and we're gonna play a slightly different hurt animation. And then here he's passive hurt. Okay, I get it. So we have different layers. All right, and the base layer is override. This is like our core. It's written onto the bone structure, the skeleton of this animated mesh. And this is just added on top. And so we have two layers. Take a look at the masking later if we need to. The weight means take 100% of whatever's happening in this animation layer and add its effect onto the override layer. So you can reduce the effect if you wanted to. All right, these are some important concepts. Let me know if they're a little confusing. And then in our parameters, we have is active trigger. That's right. It's it's a bool. So it's either on or it's off. It stays on or off. And it's a square. And on damage is a trigger. It just happens instantly. All right. So what's happening here is we have these transitions. So we have our idle animation. So maybe before I go into the transitions, we can take a look at the animations. So here's the idle animation. So when it says animation clip is read only, this means the animation wasn't created in Unity. It was created in a Maya, Max, some other package. I'm like, yeah, sure. Show me what the animator created. We imported this. The animations were imported in. There's a whole process of how to get your 3D meshes and your 3D animations from your content package into Unity. But this was all these animations were created and imported into Unity. And so here we have the idle animation, and here's all the bone structure. And so for each joint, you can animate, change properties on position, rotation, scaling on the transform. This is conventional 3D animation. And the way the bone structure works is, I don't know if you can actually look at it. And I'll try to show as anything about it as I can, so it makes more. I don't want that. Where's the mesh? It's sitting up here. Oh. Yeah, it's probably all these pieces of it are sitting throughout. Give me a second. Oh, sorry. Turret bottom, turret center, turret top. So, skinned mesh renderer. That's not the fun thing. Oh wait, did I just see? I thought I saw. All right, this is what the little mesh piece looks like. Vertices, indices. I talked about them when I went through computer graphics, but skin, 4 bones. I'm not sure if it's going to show me the bones, but think of them as points that, like, you kind of paint their influence on all the vertices. And with robots, usually it's more like, oh, this polygon face or this vertex belongs to this bone. It's called hard surface deformation. And for you have soft surface for more like humanoid or like soft body people. But anyway, when you animate, I'll quickly show. there's any type of image that'll make a little bit of sense to what this is, because we're not really focusing on that in class. But yeah, so you can see the mesh, and underneath is the bones, just like a skeletal bone and like a real body. But you animate on the bone. So like this knee bone here, this right knee bone, is all this mesh area is like highly impacted when you rotate the knee, and a little bit rotated down here and a little bit up here. And if you rotated the hip, the all these bones, these child bones, would be rotated just as, you know, as parenting childing with game objects. It works the same way. And so the whole leg, like they would, all this mesh that's connected to all these bones on this right leg would move with the bones. So instead of like animating on all the little vertices, you skin the vertices to the bones, and then you have far less things you need to animate. But when you do this, you need to bring the whole rigged, skinned bone system along into Unity for the ride, and that's why we have this thing called skinned mesh renderer, and it's a mesh just as you know it to be, and then there's a bone system, and this is the bone system up here, and this is what's animated on, and it's like, and the bones have control over changing the position, rotation, and scaling of the mesh vertices. So anyway, just like you would place down keys and you would animate position, rotation, scale, or transform properties to create animations. And so here's idle, and here is attack in, or transitioning into the attack. That's just played once. And here's attack loop and attack out. In addition to these getting hurt. So you see, this is what it looks like to get hurt. You really jostles, but this is getting added and blended into the attack loop animation, which is the core of it, where he's kind of standing still. So that's why it's not as crazy moving around. And the same with this one. It's like toned down because it's blended, added into it. So these animations are coming from that third-party package. So now that you saw the animations, we have the idle animation is transitioning to attack in when is active. This parameter gets set to true. And here's the blending time of the transition. And so this is what it looks like. Blah, blah, blah. Then there's the transition real quick to settle in. And then this is us, and notice has exit time. Just plays animation and just go right into attack loop. And when is active is false, we come out to our attack loop to here. And this is just has play the animation and just exit. It's a time condition. And come back. And for damaged, we're in null, and when undamaged gets triggered and is active is false, we're going to passive hurt, and passive hurt has exit time. Just play it and leave, and exit returns into entry. We go into here, and same with this one. It's just undamaged, inactive is true. We go this way, and this is just a timing condition. All right. Animation states are playing animation files, and we have transitions designated with the parameters. This is a toggle, and that is a bool. And we have different layers now. Our base layer, which is an override, and our damaged layer, which is additive. All right. Is there any questions on all that? Okay, just let me know, because that kind of pulls back to a lot. So what's happening here is undetected. We're going to go to attack state, player VFX, and we're going to tell the animator, hey, set this bool is active to true, which makes him switch animations. On lose target, if we're in attack, go to idle, stop all our VFXs, and set bool to false. And update our time when we lost the detection. So on damage, since we're listening to the health scripts event, when we get this method called, because the on damage event gets called, we get a certain amount of damage, looks like it comes in, and who hurt us. And random hit sparks is a particle system array. If we have any particle systems we're supposed to be playing, get a random number from 0 to the length of this array, basically length -1, and go to that element, because remember it's always 0 to length -1 to access an element, and play that VFX, and then go to the animator and call trigger the damage parameter on damaged. So it looks like we have some random hit sparks. Okay, there's 3 of them. Okay, that's why it makes it some pop out here, some pop out there, some pop out there. Sure. Just pick one of them at random and play them. And it looks like in the update, we have update current AI, right? And so it's only when we're in attack mode, which is coming from the detection module, do we actually process anything. So if we are in attack mode, then should we shoot, basically? Is the time greater than the time since we detected plus our delay, our firing delay? So whenever that time gets greater, that means we're ready to fire. And then we figure our direction. So remember, we take our aim point position. We take the enemy controller known detected target, which right now would only be the player, get their position, and subtract deterrent. And remember, it's when it's A minus B, we get a directional vector from B pointing at A. So vector subtraction. B, you want to take whenever you're trying to figure out a directional vector, your starting point has to be B and your ending point has to be A. So we want a directional vector from the deterrent to the player. So it's a little backwards. And then normalize it. Whatever. I don't want to know how much the distance is, the direction. Just normalize that vector down. And so it's a unit scale vector because we're just going to use it to point at where we need to fire our bullet. And then for whatever reason, we have a little offset between the pivot and the firing point. I'm not really going to spend time in figuring out why. But somehow this, our pivot aiming rotation. So quaternion.slurp. So remember, quaternion is the class dealing with 3D rotations, and they're very complicated mathematics. And the reason that we have to do more complicated, we can't just use like nice 360 like a Euler angles like X, Y, and Z, is because in flight simulators they discovered this thing called gimbal lock, where 2 axi will like lock onto each other, and then everything just gets completely messed up. So notice the airplane. We have our 3 axi as it's like rotating around, and eventually, if you keep rotating, somehow 2 axes will just like get locked onto each other. Just the math just crumbles when you just use like X, Y, and Z rotation. So you have to use quaternions, which actually have a 4th component, W, and it gets into ideas of complex numbers, and we are not going to get into that math. So just know that there's a nice little class Quaternion to help you out there when you have to figure out rotational stuff. And I'm very happy if you can walk away with getting a better understanding of vectors and how to use them as quaternions, and figuring out rotational math with them is just like that's really for like maybe the advanced class. Like we'll have to be aware of them. So anyway, we're figuring out the rotation weapon. For some reason the weapon in the main turn pivot needs some like correction when you're trying to aim the weapon. So if we're shooting, do some correction. Oh, sorry, it was up here. Quaternion.slurp. So slurp and lerp. Lerp, linear interpolation. We've seen that. You could do that with floats, with vectors, colors. It's just a transition from A to B, and how far along are you is T, which is 0 to 1. 0 means you're at A, 1 means you're at B. Anything else means you're somehow in a journey in between the two, and we use them a lot, mostly for procedural animations. And spherically, slurping means spherical interpolation, and it's mostly dealing with when you have to lerp with rotations. You have to, I know it's a funny word, but you have to slurp. I've used slurping before when I had to do this thing where I'm throwing darts or arrows or like rubber plunge, something that's got an arc to it. And I've been able to successfully get the arc in a trajectory by doing a slurp, because a slurp is like moving along a radius of a circle instead of moving like linearly from one point to another point. So a lerp, A to B along a flat line. Slurp, we're going A to B, but along the perimeter of a circle. All right. So here we're going directly between 2 points. Here we're as if those 2 points were on like a sphere. And how do we get to those 2 points while we're following along the surface of that sphere? So this, you could see how like an arc, like throwing something, getting an arc, you could do that with a slurp. So linear and slurp. And what I had to do is I had to make a huge sphere and place the base of it at the floor. And when I threw it, like your hand is up higher, and so that's why you're at like the top of a sphere and you're throwing along this arc, landing it either to the floor or to the wall. All right, so anyway, we're moving from one rotation to another rotation over a certain amount of time. And if we must shoot, then we're going to call this try attack. And so now we're moving back to the enemy controller, and we have a position of our turret, aim point, along with some corrected direction. Sure. And so now we can move back into the enemy controller. And here's another method that we kind of glazed over last week. And pass in a Vector03. That's a little weird because plus. They're adding two vectors together. Okay, vector addition. So ultimately get one vector. So the enemy controller is like, hey, where is this enemy I'm trying to hit? Which looks like is wherever my turret aim point plus corrected direction is. It's like where I'm trying to shoot. Might not necessarily be where the enemy's actually located. It might be like where I'm thinking I'm trying to shoot based on whatever math in my logic. Okay, so if the game is ending, so I guess if the player just died but the cannon's still shooting at you, just don't do anything. If the turret's still shooting. Otherwise, orient the weapon towards the user. Okay, so that's another method. Okay, here it is. Public void orient weapon. So for each of your weapons, we're going to find your weapon forward and put the local forward, the transform dot forward, put it whatever your calculation was. If the last time the weapon swap plus the delay, since the swap is greater than time, then we've swapped the weapon. We can't fire yet. Okay. Shoot the weapon. So return. We're done at this point. So if we're still moving on, we're still actively shooting. So get current weapon and try and control method on it. Handle shot inputs and seeing if we fired or not. So get current weapon is down here. So then that calls find and initialize all weapons. It's up here. I kind of hate how you like jump around methods. Sometimes I organ like this should be after this one because this is being called, but whatever. Sometimes multiple methods are calling one, and it's not so easy. So if our weapon is null, go down into the children game objects and find the weapon controller so that we can have a pointer to it. So the weapon, I guess it's down in here. So somebody's got, so this has a damageable. So let me turn on this. So this thing, it's a box collider. It's got damageable on it. This just turn top, turn center, turn bottom. VFX. Oh, here's the weapon root. Okay. So it looks like it follows this whole hierarchy because it's moving around during the animations. Okay, and here's the weapon controller. So now we're going to go down and find it in my hierarchy, get a reference to that script. I don't want to enter the weapon controller of this class if I don't need to because I'm already hitting upon a lot of concepts with you. So get components. There could be multiple weapon controllers on an enemy or even a player. And so this might return more than one, an array. So for each one, go to each weapon controller and set its owner to this game object. All right. So we found and initialized all our weapons. Pretty straightforward name. After that, if we still found no weapons, then set current weapon to 0. Set the first weapon of the weapons list as a current weapon. Okay. And then whatever, return this thing, which we just found and initialized. Set current weapon. Which index, which of our weapons of this array of weapons is our active weapon, and are we swapping or not? Okay, so anyway, all that get current weapon. Notice this is a method call, so that's why I went through that code. All that code gets run, and it returns back a weapon controller. And in the case of the turret, there's one. And then go in and call handle shot inputs. False, true, false. Let me see how much time I have. Let's look at the weapon manager. I don't want to open up yet another script. So anyway, this is returning true or false if like we did actually fire this weapon. So if we did fire and on attack is not null, so on attack is a unity action. So if anyone's listening to us, the enemy controller, and we just fired, let's invoke on attack, and whoever was listening to us will call their methods. And if swap to next weapon, and we have other weapons in our list, then go ahead and swap the weapons, sure. And return, did we fire or not? Okay, so that was try attack. And where was this coming from? Let's see. Okay, enemy turret. Called it here. So all this is doing is it's calling that method, and then we're done. Okay, so ultimately we figured something happened here in the weapon controller, but we also got on attack invoke. So let's see who's listening to on attack. Oh, sorry, I'm over at enemy mobile. So it looks like enemy turn and enemy mobile. Listen to them. Let's see. No, undetected, unlost. So it looks like I'm not ready to go into mobile just yet. But it looks like mobile. When you do attack, it looks like enemy mobile does do something. Oh, it sets another animation. So we'll look into the animator of enemy mobile. But it looks like when they figure out that they are attacking, there is another animation that's being played, but only on enemy mobile. There's a trigger. Cool. So I think I went through all turret with that. There's some update turret aiming. I'm not really interested. Some rotational turret stuff. I'm not really interested in getting into that. So it looks like we covered enemy turret really well. And then we covered the animation. So let's go look at enemy hoverbot and see what its animations are doing. And ask away if you have any questions. All right, so he looks a little different. Got some different parameters, got a different state machine. Looks like we got some different layers. So I'm going to click play on them. For some reason, it needs to rebuild a lot. Okay. So, what layer? We're on base layer. We have patrolling. Looks like we go right into patrolling from our entry point. And let's see what happens with parameters. So we have attack. We got our move speed. It's showing something. Somebody's updating our move speed. Let's see if we're alerted. Oh, nice. It jumps. It looks like we're in a different base layer. Now we're in the alerted layer. But there's nothing around, so he just keeps patrolling. Undamaged. So he looks like he's getting hiccups. On death. Attack. Okay. So it looks like we have patrolling, and he's like following a path from that nav mesh. That so he must be the enemy controller or enemy mobile is telling him where to move amongst this nav mesh, and I'll look at that blend tree in a second. So we have attack layer, which is additive, and it can only shoot and then go back. And so that must be this attack right here. Yeah, we go into shoot. He just does this like opening up to shoot. Then we have the damaged layer. So if he's hurt, so on damaged here, on damaged, you can see him. That's what it looks like when he gets damaged. And that's additive as well. So we have two additive layers that all get added into the base layer. And So there's this locomotion layer, like alerted. There's something else up here. Oh. This is weird. Let me unclick play. Okay, we have a blend tree. Up. Okay. Wait, that was hard to, it like kept popping off of this base layer. So here's the base layer. We go into an idle, we go into a locomotion or alerted. And so notice these aren't layers. It's not like attack damage. These are additive. These, no matter what, these can get applied on top of. It looks like base layer has some, they must be, okay, sub-state machines. That's what this like shape means. So when we're idling, we looks like we just go right into locomotion. And oh no, sorry, move speed has to be greater than 0.05, and alerted is false, so we go to locomotion. I don't know why this isn't supposed to have exit time. And this is if our move speed is less than 0.05, we go to idle. If we're alerted, we go up there. If we're not alerted, we go back. And if we're moving and alerted, we go up there. And if we're not moving, we're not alerted, we come back down to idle. Okay. So now we're in like sub-trees, sub-state machines, but we're still in the base layer. And so this is, we're patrolling is the default. And turn left. I got a feeling that these aren't being used that much at all, but I'll take a look. So if, okay, so this means we leave. So right now we're in the locomotion subtree, and it looks like we go back. If our move speed is less than 0.05, we go back to that base layer, and we come in out of that base layer with this. So that's the same as these right here. It's just a different symbol. It's like showing we're coming in or out of this sub state machine. And then alerted is we're following. We just go transition right into following the enemy. And if these conditions happen, we just go back to normal, which is idle. Okay. So not really sure. So now you're exposed to create these sub-state machine layers. I'm not really sure you needed all that, but maybe they did. So if you look at the animation, he's probably got a lot of animations. Yeah, some of those states like aren't even being used, it looks like. So idle closed. This is just him idling. He's not patrolling, which I don't even think he ever really does that. If he's running forward, this is what he looks like when he's running. Notice he's actually stationary, so he's just like bobbing up and down, looking like he's running. The actual moving of the position is going to happen in that enemy mobile script when he's running forward closed. I guess closed meaning maybe he's patrolling, but his like his shooter area is closed, like he's not actually trying to shoot. Here's him shooting. Idle, hurt, and alerted. Okay. So there's some states that like this turn left, turn right is not being used. Unless, no. So this is a blend tree. We don't need to get into this. This is where you can, this is when you get like really complicated humanoid turning, running, diving, jumping, ducking, looking around corners and stuff, and you'll use these like really, but I see that there's no motions connected to this, so just ignore that. Looks like these turn left and right are not used. So alerted. So I really think this could have all been done in one state machine, but whatever, sub-state machines. Cool. And I don't know if I want to. That was quite a bit. I don't know if I want to get into the whole. Because this is going to be like, how are we finding points on the nav mesh? And I think I'm going to hold off on that because that was a pretty deep, some complicated topics. So we have turret. We went over the animator. So we have the. So still have the weapon controller, and that's going to go into the prefabs. And that's going to go into project. Oh yeah, that's fine. We still have two classes. Okay. So I'm going to move this around a little bit. Like it's like really hard to edit this. I don't know why they make this stuff so hard. I'm going to move the hover bot. And we did that. And then when we cover the hover bot, we're going to have to figure out the nav mesh. Okay. So on Friday, we could do hover bot, nav mesh, start to go into the weapon controller. Could pick that up last class, look at the prefabs, projectiles. And so that'll be a nice conclusion. I'm not going to go into any more of the game manager scripts unless people are interested in that. I'm pretty much just going to wrap it up there, and then we can spend the last sprint. Yeah. And we can start up on the driver. Okay. Cool. Let me know if I have any questions. Otherwise, I'm going to stop the recording.